In the last lesson, I introduced you to control flow statements, and I explained that this is a mechanism you can use in order to limit the execution of a segment or block of code based on a certain condition. Now in this lesson, I am going to explain exactly how this is done, both in terms of how you do this in C and also in terms of how your computer does this behind the scenes. First, we're going to look at how your computer does it, and then in the next lesson we're going to look at how to actually do it in C. Just for a moment, I want you to imagine that your computer needs to compare two values in order to see if they are equal. Let's suppose 5 and 3. How can this be done? How exactly is an electronic device like a computer able to perform comparisons? It may surprise you to know that one of the ways that your computer compares two things in order to see if they are equal is by using subtraction. If any two values are subtracted, then it is very easy to know if they are equal. How? Simply by determining if the result of the subtraction is 0. Anytime two values are equal, the result must be 0. Now, on the other hand, if the two values are not equal, then the result will not be 0. Now, we do not need to know what the actual result was when we're comparing two values in order to see if they are equal or not. We just need to know whether or not the result of the subtraction was 0. Keep in mind that it does not matter how you subtract the two values. Whether you say 5 minus 3 or 3 minus 5, it's still going to be the same, meaning that the result is still going to be 0 only if they are equal. If they're not equal, the result will not be 0. So to recap, here are the two steps in order to determine if two values are equal. First, you subtract the two values, and then you simply check to see whether or not the result was 0. If the result is 0, then the two values are equal. Now, of course, you need to keep track of whether or not the result was 0 for later on. Notice that you do not need to keep track of the actual result of the subtraction. You only need to keep track of whether or not the result was 0. Now think about this. How much space do you need in order to do this? How many bits? The answer is that we only need a single bit. We can set that bit to on if the result is 0, and we can set that bit to off if the result is not 0. Now, from an earlier lesson, you should remember that a single bit being used to store a single true or false status is called a flag. So if we set up a single bit to store a 1 or a 0 based on whether or not the result of a subtraction was 0, we could call that a 0 flag. Now let's imagine that we are actually going to design a CPU chip, and we want to give that CPU chip the ability to compare two values. Then how would we do that? Well, first of all, we would compare two values, and this means subtract them, but to do so in a way that the values don't actually change. And we would need to create a machine code operation for the CPU that would do this. So let's call that compare. Next, we need to design our machine code instruction in such a way that if the result of the comparison or subtraction is 0, it automatically sets our 0 flag to 1 or on, and otherwise sets the 0 flag to 0 or off. Keep in mind, the whole purpose of the 0 flag is to keep track of whether or not the two values are equal. How? Because by subtracting the two values, you're either going to get a 0 if the two values are equal, or you're going to not get 0 if the two values are not equal. So we have a single flag, a single bit that keeps track of this for us that we call the 0 flag. The last thing that we need in order to truly have a way to execute code conditionally is we need to have a way to jump over the code that we're not going to execute if the condition we are testing for results in that outcome. So we need a way to jump over the block of code that is associated with the conditional flow statement, but only if the zero flag is off, meaning if the comparison fails or the two values are not equal. So we could call this machine code instruction jump if not zero. Now, very briefly, let's review what the if statement in our previous example looked like. So basically we have some programming instructions or statements, and then we get to a line of code that sets a condition to be tested for, and then if the condition is met, it's going to execute the block of code. Let's imagine the condition we were testing for was to see whether or not 5 is equal to 3. Which obviously it is not, but we can use that as an example. So how would this actually break down into machine code? The answer is we only need two machine code instructions. We need to compare 5 and 3, and we need to jump, if not 0, to where the program continues, right here basically. So that's all you're going to do. So when you get to this line of code, at the machine code level, what's going to happen is 5 is going to be compared to 3, which means there's going to be a subtraction. And then, if the result is not 0, it's just going to jump over here. What then happens if the result is 0, which means they are equal? Well, then this block of code is going to execute because there's nothing saying to jump over it. So if there's nothing saying jump over this block of code, then it's going to execute normally. And that's all there is to it. With only two machine code operations, we can do an if statement. Now you can see exactly how your computer is able to perform conditional flow statements behind the scenes. Now, before I continue, I want to show you something. What I just showed you is not hypothetical. There are many programming languages, and what I just showed you is a simplified version of something called assembly language, which is a programming language that allows you to write code at such a low level that every instruction you write gets directly translated into machine code, ones and zeros. So a programmer writing assembly language, rather than writing out actual ones and zeros for each instruction, is going to use short, easy to understand mnemonics for these instructions. Now, if I wanted to change this example to actual assembly language, all I would do is make it look like this. And that's it. The word compare just becomes CMP, which is the actual assembly language instruction for compare, and JNZ is short for jump if not 0. And of course I would replace this with the memory address that I want to jump to, which would be the memory address for where the program continues. And that concludes this lesson. In the next lesson, I'll show you how to do this in C.